So let's start here. Yesterday we discussed about introduction to Hadoop, and also yesterday we talked about functional programming language. So we talked about why functional programming language, what is functional programming language and why Scala is being used, why Scala is in demand nowadays. So if you recall about the functional programming language, I said that it is all about avoiding mutability, and also it is all about writing pure functions, and it is also all about having a clear cut difference between mutability and immutability. Keeping those things in mind, keeping those things in mind, we can run some examples here. So you have to just, the way you have to configure here is, you don't have to do anything. You have to install Oracle VirtualBox. It is just download the Oracle VirtualBox. Any latest version should be fine. Any latest version should be fine. Just download it. It is just a simple a Windows software. Download it for Windows and just click on next, next, next. You should be able to open it. Here is a question, whether this works with VM Player. It will work with VM Player. You have to retry it once again. It will initially fail and it will ask for retry. You have to retry. But I recommend it to work with the VirtualBox. If you are comfortable with virtual VM Player, then you can go with VM Player. But I recommend the VirtualBox. So once you install VirtualBox, you should get this. And after that, just double click on the image. Double click on the image or just say import. Either of the one. Say import and select the image actually. You have to just select the image. Press OK. Initially, later you have to make few changes. Just let me know if you are facing any problem. Configure your configuration has to be slightly different. Let me see which one I can. Yes, Vipin. I have providing those things. So you have to just open it and import it. Just let me know if you face any problem. We can sit and solve it offline. Not much thing has to be done. It will automatically boot up, and the username and password is Kafka 123. Kafka is the username. It will boot a Ubuntu image, and the username is Kafka. Password is Kafka 123. So once you log into your system, so you can open the terminal and start your Scala. As I said, I will be explaining not everything here, only the required things. if you want to practice Scala, again all the things are there in the Google Drive. So if you go to the training folder, so there is a Scala folder. I have shared the training folder, Scala folder. So there you can go and check with the Scala training.ascii. Open this document and all the examples are available in this document. You can try working on these examples.
We
Yeah.
need to import the images in the Google Drive. Pramod.
Sorry. Tell me, Ramkrishna.
So I have installed the Oracle Virtual Box.
Okay.
You are asking me to import something. So import an image.
Correct.
Where is that image located? Is that in the Google Drive?
Yes, you have to download that image from the Google Drive. That image size is around 9 GB. You have to download
Okay.
that. Uh, I hope you have shared your email ID, right? And
Yes, yes. Okay.
yeah, you are able to see my access my Google Drive, right?
Yes, I'm able to access your Google Drive.
Yeah, you have to download that. It will take time because it's a 9 GB file. Once you download it, try doing the setup. It is just import from the VirtualBox. Keep all the defaults as it is, then you can start. Only thing you have to know is how much CPU core and RAM you have to assign. What I'm trying to say here is when you say import, so as you see here, it will just ask you for next. So here, what is the RAM you want to configure? You can configure here. What is the CPU core you want to configure? You can, if usually most of the laptop has, you can configure 2 cores, and RAM you have to configure based on your size available. My laptop has 16 GB RAM. So if you see, if I click on the systems here, my laptop has 16 GB RAM, so I have allocated 11 GB to this virtual box. So based on how much RAM you have, you assign correspondingly. If you have around 8 GB RAM, try to assign try to assign 5 GB RAM to this virtual box. Go to image, Scala, press next. Here if you have 8 GB RAM, assign 5 GB RAM. I mean minimum 8 GB is required. So after that, then just say import. That's all. You don't have to do anything. It will take some 10-15 minutes to import based on the CPU core that you have on your system. It will be some 10-15 minutes. After that, it will log in, and the login username is Kafka. Password is also Kafka. So I hope that could be done. Here is a question from uh, Vipin. Vipin, I am using Maven here. I'm using Maven. You can use some examples. Some are in SBT, and some are in most of the. When I start with the Scala, I will be explaining on the command prompt, Scala command prompt. When we move on to Spark, Everything will be on the IntelliJ. We will be using IntelliJ here. Here, log analysis is Maven project. E-commerce is a Maven project. Spark 2 experiments is a SBT project. So all the combinations are available, but initially we will be going with the Scala prompt. For understanding purpose, for simple examples, I will be using Scala prompt. So if you remember yesterday we talked about immutability. So functional programming is all about avoiding immutability. So based on that itself, Scala has val and var. This is the reason Scala has val and var to differentiate, have a clear-cut differentiation between immutability and mutability. They simply did not add those val and var. They were added because they wanted to clear-cut differentiate between mutability and immutability. Val means immutable, you cannot change. Var means mutable, you can change. Similarly, Scala collections are immutable by default. If you see the Java collections earlier, Java collections were not immutable by default. If you take an array in Java, it is mutable by default. They simply did not make Scala collections uh, immutable by default. So a lot of thinking was gone because of this functional programming language, functional programming concept. So they have made Scala collections immutable by default. It is by default, meaning you can also get mutable collection. But whenever we say list, whenever we say a list or set or sequence or map is nothing but hash map, or whenever we say these collections, these collections are immutable. So if you want a mutable collection, you ask for list buffer. You have to explicitly import. You have to explicitly import these collections. So keeping these things in mind, so val and var, let's see how it works. Is there a disturbance here from my side?
No.
Okay. So this is how you say val x equal to something. So here val means, as I said, you cannot modify it, meaning x equal to, you cannot assign some other value to x now. It will throw a exception. Error saying reassignment to val. In a similar fashion, if I say val y is equal to 30, sorry, my mistake. If I say val var y is equal to 30, now you can modify the value of y here. So it allows you to modify. So that's the difference between mutability and immutability. Immutability, you cannot change the value. Mutability, you can change the value here. Also, if you see here, we did not specify the data type of the here. Usually we used to say in Java, int y equal to something in this fashion. But we never use the data type here. We just used val and var because the data type is automatically inferred by the compiler. Compiler takes care of these things. We don't have to worry here. So as you can see here, since I have assigned 30 to y, since 30 is an integer, the Scala compiler has automatically inferred it as a integer. We don't have to explicitly specify. It is not mandatory, it is optional. So if I say val d is equal to 10.5, it will automatically infer it as a double. In a similar fashion, if I say val s is equal to Scala, it will automatically infer it as a string. We don't have to explicitly specify. In a similar fashion, if I say val b is equal to true, it will automatically infer it as a boolean. I mean, these are all the basic things. Just like any language supports the basic data types, Scala also supports the basic data types. Again, I will repeat it once again. Scala is based on Java itself. Scala is a JVM based language. When you compile your Scala code, it will generate byte codes, which is your Java byte codes, because it runs on the and that byte code can run on the JVM. So if you use some decompilers, online decompilers are available, or from IntelliJ or Eclipse decompilers if you use, you can decompile your byte code and you can see that it will be the Java code. It is a JVM based language. Just need to keep that in mind. So here is a question. The question is, can we define data types if we want to? We can define the data types. I mean, defining the class itself is defining a data type. So here also we can define the data type. We have to just say define a class. That class itself is your new data type. I hope, Shruti, that was clear. Now, as I said, this is optional. The data type specifying is optional. You can, if you want to clear the Scala shell, Control L is the one. I mean, you can clear it. Control L, it will clear and go to the top. So I keep on using the Control L command. If you explicitly want to specify the data type, okay, that was the question. Oh, I misunderstood your question, I suppose. So I think you are asking, okay, if you explicitly want to specify the data type, then you can also specify that. So if you want to say, this is how you specify the data type. So data type always comes at the last. Colon, int. Colon and int. You can remember in this fashion, the Scala compiler says that I will infer the data type for you. You don't have to worry. But if you want to explicitly specify it at the last. So data type always comes at the last. The use is something like this. So sometimes you want to specify integer means 4 bytes here. So there are different options available. I mean to say, you have long, you have int, you have short, you have byte. These are all the different numerical data types. Similarly, uh, decimal point data types like double and float are available. In numerical data types, default is integer. In decimal data type, default is double. Whenever you define a decimal data type, it will be by default double, which is 8 bytes. Here float is 4 bytes. Long is 8 bytes, integer is 4 bytes, short is 2 bytes, byte is single byte. So if at all you want to I mean to say here as we have val x and as we have var y. So we have two different things, val and var. So we'll use here to name these things as identifiers, because I cannot call them now variables. Variables means it will vary, it is modifiable. So hence I will not call variable. So the jargons that I will be using is x is a value identifier, y is a variable identifier. So identifier is the name we are associating. So henceforth in further also I will be referring these things as identifiers. So if you want to define an identifier, long identifier, so there you can specify the data type. Here is a question, Arindam. If we create any type, we can use it for int, string, etc. Then why don't we directly define any? So here is a question. The question is based on the Scala hierarchy. If you take the Scala hierarchy, is there any much better picture here? The question is this. This is how the Scala hierarchy looks like. So all our integer, so in all the basic data types comes here. Integer, I mean short, as you see, byte, as you see, long, float. So the question here is, everything is a subclass. As you can see, any class is the top class. I don't know. So any class is the top class here. So the question is, if you define everything as any, you don't have to use the long, float, or integer. The idea here is, it is just a template. Any is a template. When you programmatically write any program, programmatically you don't know which data type it is. Every time you have to check whether it is an instance of integer, whether it is an instance of double, then perform the double operation, then perform the integer operation, or then perform the string operation. So every time you have to check which instance it is, because the compiler will not know internally which instance it will be. So programmatically we have to every time check what instance it is. So any is just a type here. So general type for the sake of programming. So when do we usually use the uh, data type explicitly specifying? So when we want to explicitly specify the data type, whenever you want to have a short, instead of val x equal to 10 by default is integer, when I say val z, if I want only 2 bytes of memory to be allocated, so there I use short. So that's where you explicitly specify the data type. Otherwise, data type is not required. So if you want to choose something here, if you want to choose one among these, so there you use the data type specifying explicitly. And long you usually specify val a is equal to, you just have to say L here. So this will automatically make it as a long. In a similar fashion, val f a, so a b is equal to 10.5 f. If you say, it will automatically infer it as a float. So all these are the basic data types that are available in Scala, similar to the basic data types that are available in any other programming language. Nothing difference, only thing is val and var. Here one confusion I want to remove here. One confusion I want to remove. The confusion here is when I say val x equal to 10, I am able to recreate it again and again. As you can see, again I can say val x is equal to 20. It does not mean that we are doing mutability. I said that val is immutable, and just don't confuse it with that we are doing mutability here. Here the original object is destroyed and a new object is created, and it only happens in the shell. It only happens in the Scala shell. If I write the same thing in IntelliJ or Eclipse, it will throw an error that X is already defined. So that confusion you have to just ignore that. So I hope till here things are clear. So here there is one more data type called as a tuple data type. So this is new to language called as tuple. So tuple is nothing but, you can imagine, just like a row in a database, which is nothing but a grouping of multiple data types. So tuple is also a new data type in Scala, which is nothing but grouping of multiple data type. This is what we call as a tuple. So the way you define a tuple is, you can imagine like that, but internally it is actually a class. Tuple is internally actually a class. So you can say val t is equal to, the syntax is this, that's all. You can group multiple data types here. Is my voice breaking? From here the network seems to be good. Anand, probably if there is a network bandwidth issue, sometimes just try logging out and logging in again. Because from my side it seems to be good. It says everything is in a good quality. Just try to log out and log in. So this is, yeah, this is how you define a tuple. So multiple data types, multiple data grouped together. It is not a collection, that we have to keep in mind. It is not an array, it is not a list. You don't compare it with the collection, because it is not a collection. It is just a grouping of multiple data types. And the way you access the elements of the tuple is t dot underscore 1. You will give the first element. T dot underscore 2 will give you the second element. T dot underscore 3 will give you the third element. So that's how you access the elements of the tuple. Underscore 1, underscore 2, and underscore 3. Now what is the use case of this data type? In a traditional way, the use case of this data type is to return multiple data types together from a function. You can use a tuple. Otherwise, you usually, what we do, you create a class object, and that object will be returned from a function. But you have a out of box available data type here. If you want to return multiple data types from a function, tuple can be a comes in handy. Tuple comes in handy. That is the biggest use case in a traditional programming language. In traditional software development, you can say tuple is that use case. But in distributed processing, that we will see later, in distributed processing, tuple is, I mean, the use case of tuple is totally different. Tuple is used as a key value pair usually, and that too it will be a two element tuple, and the first element of the tuple will be treated as key, second element of the tuple will be treated as value. In distributed, you will usually have a two element tuple, something like this. Something like this as something here, some count, I will say 50. So if you write, so the distributed applications like MapReduce or Spark, they will usually use a two element tuple, and they will treat the use case that they want to come up with is, they will treat the first element of the tuple as key, and they will treat the second element of the tuple as value. So that's the biggest use case of the tuple data type in distributed environment. We will see these things. As we move on to Spark, I will explain the things. Yes, Vipin. Scala after compiling, it gets converted to bytecode. It's a JVM based language. So this is how the tuple will be used. We will use these tuples later, but this is the data type of a tuple. You can define any data type. I can say val t1 is equal to something. So it is a two element tuple. Similarly, we have a three element tuple we define. So if you want to access the element of the tuples underscore 1 t1 dot underscore 2, so you get it. So as you can see here, we didn't had to specify individual elements data type. The Scala compiler automatically infers a data type. We don't have to explicitly say that. So if you want to explicitly say the data type, again it will come at the last. So you have to say string boolean. If you explicitly want to specify the data type, you specify in this fashion. Otherwise this is optional because Scala compiler will automatically infer it for you. So internally how it is implemented is, so if you remember yesterday I said that Scala is functional programming and pure object oriented program. So what do we mean by pure object oriented? So what do we mean by pure object oriented here? Pure object oriented means anything that we create, anything that is created is an object. So that's what we mean by a pure object oriented program. Anything that we create in our language, everything is an object. So there is no basic primitive data types like we have in Java primitive data types. Such things are not there in Scala. So everything is a class, and whatever we are creating is an object of the class. So when I say tuple is an object of a class. When I say when I say val x equal to 10, it is not a primitive data type. X is now an object of the class integer. So everything there is defined a class. Similarly there is a class called tuple. Class called tuple. It has members called _1, _2, _3, something like this. I mean to say there are different class. So this is tuple 3. So if you are defining a two element tuple, there is a class called tuple 2, so which has _1 as the member, _2 as the member here. So that's how a tuple is internally defined. We don't need to, go through these things because we never use such a thing. We have to just, the syntax that we use is only this. So that one thing we have to keep in mind. This is how you create a tuple. And data type will be automatically inferred for each and every individual elements in the tuple. And a two element tuple is treated as a key value pair by the distributed applications. We will go and see those things later. Always a two element tuple is treated as a key value pair. That's the biggest use case of tuple in distributed environment. So keeping this in mind, we will also see our main goal is to understand functions, all those things. As I said earlier, yesterday also, we will be talking mainly about functions, function literals, function object, higher order functions, then how the higher order functions are applied on a collections. These are the main things I shall be explaining, and other things as and we move on with the Spark, I will explain there. So let's see how a function is defined in Scala. We have already seen the syntax. So we use the def keyword and we write some function name here, product. I'll just say product. This function will take two parameters, x int, y as int, as simple as it looks like. and you have an equal to sign which differentiates your body from your function uh, syntax or function input parameter and name. So in the body you just say x star y, as simple as it looks like. This is how you define a function. And the traditional way to call this function is as simple as this. Now two things we have to remember here. Two things we have to remember. As you can see here, here we did not specify the return data type. Also, we did not use the return keyword. We did not use the return keyword. So what we have defined here is, so we have defined product x is int, y is int, and we just said x star y. So here is a question: why did we use a pipe symbol? No, it is the shell actually. It is the shell. It says that we haven't done with the statement, or the expression is not yet complete. So as you can see here, there is no return what we did not specify the return data type, nor did we specify a return keyword. So it is implicit actually. I mean, it is automatically inferred by the compiler. The compiler takes care. It is as good as saying return x plus y. So whatever is the last expression in the body, whatever is the last expression in the body of the function, so that will be returned. That will be returned from the function, and whatever the return value is, that data type will be automatically inferred as the return data type. So if you want to explicitly here since it returns an integer, the function return type is a integer. So as you can see here, it has automatically inferred that the return data type is integer. We don't have to explicitly specify that. If you want to explicitly specify, as I said, it always comes at the last. Here we are saying that this function returns an integer, and we are just saying x star y. And no return keyword should be used here. It is not required. Whatever is the last expression, that will be returned. We will come to that. We'll come to that with it. So this is a function. This is a function which returns something. Now yesterday we said that. Yesterday we also discussed that if you return something, it is a immutability function. It's a immutability function. If we don't return, it is mutability function. Now how can we have this? How can we say that, how do we make sure that we don't return something? So it is something like this. One thing is if your last expression is an assignment expression, let's say we have val g is equal to 0. So we define modify, we take some integer here, we take some integer, and we just say g is equal to g plus x. That's simple as it looks like. This is as simple as it looks like. So this function is a mutability function. This function is a mutability function. So here again, as you can see, the last expression is not a, here we are modifying the external entity. We are modifying the external entity, and also you can have one more perspective of our code, that we are doing an assignment in our body. After doing the assignment, we are not doing anything. So if your last expression in the body is an assignment expression, nothing will be returned from your function. It will not return anything. So when you don't return anything from a function, usually you say it is a void. You define that function to be void. Return data type will be void data type. In Scala, it is unit. So void in other programming language, here in Scala it is unit. Meaning that function does not return anything. So meaning usually that function has to be used for mutability purpose. It has to be used for mutability purpose. So if your last expression in the body of the function is an assignment expression, then it is a mutability function. Or you can say it is not a mutability function. It is our responsibility to make it as a mutability function. We can say it does not return anything. If last expression is assignment expression, then nothing is returned. Nothing is returned from the function. That we have to keep in mind. Now, whether to make it as a mutability function, it's our responsibility. We have to write the code in such a way that we have to make sure that we are doing some mutability. Otherwise, there is no use of this function. If the last expression is an assignment expression, then nothing is returned from this function. So if I say don't worry about this, I will just say val abc as a function. Sorry, define abc as a function, pass integer. We can say val y is equal to x plus 2 something. So this is, as we see here, there is the last expression is an assignment expression, meaning nothing will be returned from this function. That's what it says. But it's our responsibility to make sure that we use it to save something, because y will be lost here. So it is our responsibility that we make sure that we save the y somewhere. That is a developer's responsibility. Otherwise, the language as it says, it is no return type. So if you want to return something, last expression should not be a assignment expression. So you can just say y here. So it is as good as saying return y. It is as good as saying return y. As you can see in this case, Integer is the return data type. In this case, unit is the return data type. This function does not return anything. This function returns y. So I hope you got the difference when a function will return and when a function will not return. Here is a question. I think that is not required. Those jargons are not required, Vipin. It's all about mutability and immutability. That's all. Statement is a mutability expression. Expression is immutability. That's all. So they just give some jargons. Expression means both mutable and immutable. Statement is mutable. I mean, it will confuse here. Not to worry about those things. So you can just say that you are returning from a function which is immutability. If you don't return, it is a mutability. Now here is a question here. Here is a question. The question is, I will print something. So you might have used the print function in other programming languages, like Java also has a println function. C had a print function. Here also you have a println function, because this function println is a function to which we are passing this parameter. Now what is the return data type of println?
String data type.
No, it looks like a string data type, but it is not. It is not. So if you it prints hello Scala, it prints hello Scala. Let's check its return data type. Let's say val x equal to this, meaning whatever this println returns, that will be stored in x. Now let's check what will be the value of x here. So as you can see here, x data type, it says unit, meaning this function's return data type is unit. This function's return data type is unit, meaning it should be used for doing some mutability here. It should be used for doing some mutability. Now what mutability we are doing here? The mutability that we are doing here is we are writing to the console. Console is one of the output data stream. So we are writing it to the console. So we are modifying the console. We are updating the console. So that's the mutability of the function. So there is a clear-cut differentiation between a function which does a mutability, a function that does not do a mutability here. A unit is like void. In other programming language, we use void data type to signify that nothing is returned from a function. Here we use the unit data type to signify that a function does not return anything. The bigger idea is this: if you want to do mutability, your function return data type should be unit. That's the developer's responsibility. It provides these data types. The way we use this data type is the developer's responsibility. So if at all we are doing mutability, we have to have a return data type as unit. Otherwise, it is not at all required also. It is automatically inferred. You can define a function called log function. You can define a log function to which you pass a message. That message you just print. that message you just printed. So log is a mutability function here. So you have defined a mutability function. As you can see, its return type is automatically inferred as unit because your last expression in the body is println. Its data type, return data type is unit, hence log's data type is also a unit. So that's the simple thing we have to remember about the function. So if the last expression is just some expression, it's a immutability function. If the last expression we don't return, if the last expression is an assignment, then nothing is returned from the function. So then it's your responsibility to make it as a mutability function. Otherwise, it will be a immutability function. Now, keeping this in mind, and also keeping one more thing in mind, that Scala is pure object-oriented program. So I keep on saying that Scala is a pure object-oriented program, meaning anything that we create is an object. So when I say val x equal to 10, x is an object of type or class integer. Similarly, when we say val y is equal to 20, 20 is also an object of type class integer. The same thing holds good for val s is equal to Scala, is an object of type class string. The string is directly taken from the Java. It is the Java string class itself they are using. So everything is a object here. So when I say everything is an object, everything is an object, what is plus here? What is plus here? So obviously it has to be a method, because when you have objects, any operations on the objects can be only be done through methods. So plus is a method in the integer class. So internally the way it is defined is, so they have a class called int, and it has methods called plus. It can take an integer, it has a method called again plus, which can take long. So different overloaded methods are available. Short. Similarly, there is a method called minus, there is a method called star, there is a method called divide. All these are methods defined inside the integer class. So Scala extensively uses symbols to be uh, symbols as methods. You can also define symbols as methods. Any symbols can be used as, I mean, not all the symbols, there are certain restrictions, I don't remember, but most of the symbols can be used as methods. So here plus is a method. When I say val x equal to 10, and when I say val y is equal to 20, and when I say val z is equal to x plus y, what it internally means here is what actually it is happening. On X is an object of integer. On that object, we are calling the plus method using the dot reference, and we are passing y as the parameter to that plus method. So internally, this is how the Scala will treat it. But they have exposed a simple syntax to the developers. And it is not just restricted to arithmetic operation. It can be applied on any method. It can be applied on any method. So I hope you got the idea here. So everything is an object, and any operations that you are doing on object is always through a method. So always through a method here. In a similar fashion, as we said, Scala is a pure object-oriented program. Just like everything that we create here in object, because of this, internally functions are also represented as objects. Because Scala is a pure object-oriented program, even functions are also treated as normal objects. Internally, there is a class called function. There is a class called function. And you are creating objects of that function. So when you define a function, actually, internally, functions are also objects. Now, since functions are also treated like normal objects, normal basic data types objects, that's the reason they call as functions as first class citizens. This is just the jargon. Functions are called first class citizens. Now, what do we mean by first class citizens is, its meaning is that you are treating your functions also like normal objects. So it is just a jargon given to that first class citizen. So I hope you got the idea here. Now our goal is to understand what is the use of treating functions as objects. Now we know that Scala is a pure object-oriented program. Anything that we create is an object. So even functions are also treated as object. Because functions are also treated as object, it is called as functions are first-class citizens in Scala. Functions are first-class citizens in Scala. Now the question arises, what is the use of treating functions as objects? Why do we want to treat functions as objects? That is the bigger question that arises. So the use case of function objects is one of the use case, I will say, is higher order function. It is one of the use case. There are other use cases also. Higher order function. Now what is higher order function? What is a higher order function? Higher order function is a function which takes another function as a parameter. So you can pass a function as a parameter. Higher order function is a function which takes another function as its parameter. Higher order function is a function which returns a function. So we know that we can pass simple objects to a function, meaning what I'm trying to say here is, so if we remember, we defined product. We defined product. So when we call this function, so we are passing integer objects, and we are passing just integer objects. So this is a simple function. Instead of passing some simple objects, we will be passing a function here. So that's what we call as a higher order function. Similarly, instead of returning normal objects, we will be returning a function. So such functions are called higher order functions. Now the question arises, what is the use of higher order functions? So these two questions we need to address. We know that use case of function object is higher order function. Now the question arises, what is the use case of higher order? We will see this later. We'll see this later as we move on, but first we will see how to define a function object. We have been saying that everything is treated as an object. Internally, Scala also treats a function also as an object. Now as a developer, we also should be able to create a function object. We should be also able to create a function object. How can we create a function object? So to understand that, so we'll take the analogy of creating an integer object. How do we create an integer object? We can say val x equal to 10. This is how we create an integer object x. Or we can say val y is of type integer and you assign x to that. Now this is how you create a simple objects. You directly assign a numerical value to the an identifier. That identifier is nothing but an object. Or you create one more identifier y and assign already defined object. X is already defined object. You assign that value to y. Y is also an object. So this is how you normally create an object. Here integer is not required, because we know that automatically the Scala compiler will infer it. I'm just providing this to give a comparison how a function object is created. How a function object is created. We will take this pattern. We will take this pattern for comparing the how a function object is created. You have to use so what in this pattern, what we are doing in this pattern, x is already defined, x is already defined and already defined value is assigned to y. So y is a new object created. Similarly, what we will do is we will already define a function called doubler. A simple function doubler which takes an integer a and it just multiplies it by 2 and returns the value. It will just double the value, nothing fancy about this. We have already defined doubler, just like we have already defined x, and x will be assigned to y. So we are trying to create a function object using this pattern. The same way y is created, in a similar way we'll create a function object. So how do we say? We have to say val. Let's give a name here saying my doubler. Now after that we have specified integer data type. Here we have specified integer data type. Why we have specified integer data type? Because we are assigning an integer. You cannot define some other data type and assign some other data type. What I'm trying to say here is, if I say val x equal to 10, so I cannot say val y as a string and assign x. This will not work. So it has to be the same data type. If you are assigning an integer, you have to specify integer itself. Even though it is optional, whenever you are explicitly specifying, I am saying, whenever you are explicitly specifying, you have to specify the same data type as the value you are assigning. In a similar fashion, let's come back to the function object here. Let's come back to the function object. Now, just like x is being assigned to y and x is already defined. Similarly, doubler function is already defined and I want to assign this doubler function to this object. So I need to specify this function's data type. Just like we specified x data type here, in a similar fashion we will be assigning doubler. I will be assigning doubler here. Now I need to assign this function's data type. I need to specify the function's data type. Now this is a new thing. What is function data type? What is function data type? A function data type is nothing but input data type. The syntax, I'm trying to write the syntax. Arrow mark kind of a syntax. Then output data type. This is a generic syntax of a function data type. So what will be the function data type of doubler? What will be the function data type of doubler? So input we know that is an integer. Multiplication of integer with an integer always returns a integer. So return data type is also integer. So this is the function data type of doubler function. So that's what we have to specify here. Int just as you can see, we are following the same pattern. Val y, which is of the type integer because we are assigning integer to this. My doubler of the type function data type, because we are assigning a function to this. So we need to assign that function's data type. You cannot assign any other data type. It has to be the same data type of the function which you are assigning. Dynamically, can you tell me the syntax if you want to give type dynamically? Dynamically here in the sense, I did not understand the question, Arindam. Okay, you are saying generic types. You are saying generic types. Right, we will come to that. The generic types, we will come to that. It is same as Java generics. Here also we have generic type. So this is how you create a function object. So I hope you got the idea here. How to create a function object. MyDoubler, you define an object, specify the data type. The data type will be now function data type, and assign a function to that. So this is your function object. MyDoubler is a function object. So we can try it out here. We can define a function called doubler x int, and we say x star 2. This will just multiply by 2. As you can see here, the compiler has automatically inferred the return data type. Now we can say MyDoubler, specify the data type of this object. It is int arrow mark int. Arrow mark in the sense it is equal to greater than. Both combined together, it looks like arrow mark, hence I am saying it as a arrow mark. Equal to greater than. So this says that this syntax says to the compiler that MyDoubler will be a function object. This gives the hint to the compiler that MyDoubler will be a function object. So we need to assign a function to that. I mean, I can assign any function to this. I can assign any function to this which takes an integer and returns an integer. I can define any dummy function. Some dummy, it takes integer, and I can write a lot of code there. Val y is equal to 20, val p is equal to x star y, then just return p here. So if you see this function, this function also takes integer and it returns integer. So I can assign that function also. I can just assign dummy also. Only thing that has to matter here is the data type. The function, whatever you are assigning to this object, that should match the data type. You cannot assign some other function. If I say uh, xyz function, some function which takes a string and returns the string as it is. Let's say it takes a string and returns. So this function you cannot assign. I cannot assign xyz because there is a clear mismatch here. Because we have defined our function, we have defined our object to be to assign a function which takes an integer and returns an integer, but xyz takes a string and returns a string. So I hope you got the idea on how to create a function object. So this is how you create a function object. This is how you create a function object. I mean, this is one of the way. You have already defined function. You have already defined function, then create an object and assign the function. So what I'm trying to say here is we have already defined function. So then we create an object which takes integer, returns integer, and we just assign doubler to this. This is one way of creating a function object. We have already defined function, create an object and assign that function. So you get a function object. So this is similar to saying you have already defined x and you are creating y object of type integer equal to x. Already x is defined, you assign the defined x to y. We are following this pattern. So can we create a function object using this pattern? Can we create a function object using this pattern? I mean, you don't define a function and then assign it. Don't define a function and then assign it. Directly create a function object. I mean, here it is not required to define a function. In the earlier case, we defined doubler function, then we assigned it. Instead of that, can we directly create a function object? We can create a function object directly. So to understand that, so we know that what is this called? 10 is called as a value. It is an integer value. It is called as double value. 2.5 is a double value. Similarly, this is called as a string value. All these things are called as values. There is one more name given to this. One more name given to this is literals. In a programming language, it is also called as integer literal. 10 is an integer literal, they say. 2.5 is double literal, they say. Scala is string literal, they say. This is a jargon they use. Integer literal, double literal, and string literal. Now we can give a new things to this. We can give a new definition for this. It is called as values and it is also called as literals. Now what we can say is, when I say val x equal to 10, what we are doing here is we are giving a name to this literal. X is the name given to this integer literal. When we say val y is equal to 2.5, what we are saying is y is the name given to this double literal. Similarly, when I say val z is equal to Scala, what it means here is we are giving the z is the name given to this string literal. So just one more perspective to look into this. If I so one more perspective to give a literal is, one more definition or perspective for the literal is nothing but a, a, a literal or a value without a name. Literal is value or literal without a name. If you remove the name, we get a this literal. If you remove this name, we get the string literal. Here we get the double literal. In a similar fashion, can we give a definition for function literal? Can we give a definition for function literal? Normal literal is nothing but a literal without a name, a value without a name. This is our literal. If you remove the name, we get the literal. In a similar fashion, can we say anything for a function literal? A function literal is a function without a name. If you remove this name, this is your function literal. So I hope you got the meaning of function literal here. A function literal is nothing but a function without a name. Sometimes it is also called as anonymous function, usually in Python. So I hope the function literal was clear. What is a function literal? Just like we have a integer literal here. Integer literal is nothing but a literal without a name. Similarly, function literal is nothing but a function, I mean, without the name. The only thing is, in Scala, the syntax is, when you want to use a function literal, you use the syntax arrow mark. You use the syntax arrow mark. In Scala, we use that syntax. Otherwise, a function literal is nothing but a function without the name. If you remove that def keyword and the function name, so this is your function literal. Now just like we are saying val x equal to 10, a integer literal has been assigned to x becomes integer object. A integer literal is assigned to x becomes integer object. In a similar fashion, if I say val abc something, assign a function literal to that, it becomes function object. A function literal has been assigned to abc. abc is a function object. Just like a simple integer literal has been assigned to x, x becomes integer object. In a similar fashion, when you assign a function literal to an object, that object becomes function object. So I hope you got the idea of one more way of creating a function object. I can just say my doubler equal to integer function literal. So which follows this syntax. So either what the idea here is, either you already define a function or there is already defined function available. From that function, if you want to get a function object, you use this method. You use this pattern. If you just want to create a function, you don't want to, you don't want to define a function and then create a function object. Something called as inline. In Java, we have inline. Then and there itself, you define a function. You don't declare, you define the function then and there itself. So something kind of this. Functions objects use cases are like inline functions. Then and there you want to use that functions. You don't want to define the function. You directly create a function object without defining the function. So that is the, for that you need to use this syntax. Now we are only creating function objects here. We did not do anything else. We just saw how to create a function object. Either you create a function object in this fashion or you create a function object in this fashion. Because our basic idea here is the use case of function object is higher order function. Later we'll see what is the use case of higher order function. Just keep in mind that function objects will be used for those purpose. We haven't seen the higher order function yet. We have just seen the syntax of creating a function object. But I hope you got the idea of creating how a function object is created. And any questions still here? Was I able to convince clearly? Was I able to convey clearly? Okay. So keeping this in mind, let's wind up the session here, and let's continue tomorrow. Tomorrow we'll see what is higher order function, how higher order function are defined, and we'll see also the use case of higher order functions along with the collections. So whoever has not shared their email ID, please do send me a mail to pramod@datamantra.io. So please send me a mail, so I shall be sharing all the details. Yes, also please ping the WhatsApp number. You can send me your WhatsApp number because we already have a group, so I can add the members to that.